Okay, so now we're going to learn another type of factoring. It's a lot like the man method that we just learned. Now, you've probably done this type of factoring before, and there's many different methods of factoring these types of trinomials. We call them complex trinomials because instead of it just being x squared here, we have this 3. And before we said, well, we always check for common factor, and if that 3 factored out, that'd be great. But in this case, we notice it doesn't divide into the 8, so it doesn't. So we have to leave the 3 there and still find a way to factor it. Now, there's other methods that you've probably learned. There's one called decomposition, and there's various other ones as well that are sort of like decomposition. But the method I'm about to show you, I think, is the quickest, easiest, fastest, most efficient way to do it. So we're going to call it the complex man method because it's a lot like the man method that you just learned. It has an extra step or two. So just like before, we're going to have to, first we notice there's trinomial, we notice that there's no common factor, and we notice that it's complex. So we can't just use the normal man method, we have to use the complex man method. So we start the same way. We're going to go M-A-N for man, and we're going to put our equal sign, and we're going to put 2 brackets, but now we cannot just put x and x because of course it has to multiply to 3x squared. So we're going to look for the number that multiplies, but it's not going to just multiply to the negative 3. It's going to multiply to 3 times negative 3. So it's going to multiply to negative 9, the 2 numbers that we're looking for. And it's still going to add, like before, to negative 8. So this part, now that we've got the negative 9 and the negative 8, it's just like before. It multiplies to a negative, so our numbers are positive and negative. We look for numbers that multiply to 9. 1 times 9, oh yeah, that one works well. We'll put a negative 9 and a positive 1. Now, here's where well, there was that little extra step there, but now the extra step is I'm going to take my 2 numbers, positive 1 and negative 9. Remember when I multiplied by 3? Now I'm going to divide by 3. Of course, we don't want to just multiply by 3. That changes things. We're going to divide by 3. Each number that we just found, we're going to divide by 3. And here's the part that's important to get this to work right, is we're going to reduce our fractions. So 1/3 is already reduced. We can just leave it. Negative 9 over 3. That will reduce. It's negative 3 over 1. We're just reducing. They're both divided by 3. So now that you have these 2 fractions, we can now transport, this is where the algorithm part goes in. We start at the bottom, of your fraction. So like 3, and we're going to put it in here. 3x is the positive sign in front, plus 1. And same thing on the bottom, 1x, or just x, negative sign, negative 3. And we're done. Wasn't that easy? Okay, let's try another one. All right, so same idea. It's a trinomial, and there's no common factor. So I have to use the complex trinomial man method. So we're going to go equals. I'm going to put my 2 brackets. And I'm going to over here man, M-A-N, and I'm going to say, okay, multiplying to not 9 as we normally would, but 2 times 9. So that would be positive 18, and adding to negative 9. So now I just go ahead and find those numbers. Now this time it's multiplying to a positive, so I have to remember it could be 2 positives or 2 negatives, so I check with my adding ones, so it has to be 2 negatives. So I'm going to have negative and negative. And multiplying to 18, I have 1 and 18. I have 2 and 9. Those aren't working. My goodness, is there any? Oh, yep, one more. 3 and 6, there they are. Negative 3, negative 6. But I'm not finished because it's the complex method. I now have to go and divide them both by 2. The number we started with. And now I'm going to say I have to reduce, so I'll reduce them over here because I'm running out of space. Maybe I can just put them right here. That's going to be negative, okay, let's move that up. Negative 3 over 2 and negative, now I'm going to divide those both by 2 rather, negative 3 over 1. So now I start at the bottom, always start at the bottom, and I'm going to go, okay, that's 2x minus 3, 2x minus 3, and 1x, or just x, minus 3. And we're done. See how easy that was? Okay, last one. All right, so it's a complex example, but don't forget to always start by looking for a common factor. And I see a common factor right away is 2. So I'm going to take out the 2, dividing each by 2. 5x squared minus 4x minus 1. So even after I've divided out the 2, I still have a 5 there. So I still have to use the complex man method. So we'll do it again. No big deal. We know how to do it now, and it's easy. So leave the 2. Leave that 2 alone. It just sits there like a lawn ornament. It doesn't do anything. It doesn't leave, but doesn't do anything to our expression that we're trying to factor. Okay, we're going to put down the 2 brackets. And we say it multiplies. Remember, it's not multiplying to -1. It's multiplying to -1 times 5. So it's going to be multiplying to -5, adding to -4. So because it's multiplying to a negative, it's going to be a positive and a negative. And it's going to be a -5 and a +1. Now I have to remember that I have to also divide each one by that number I multiplied by in the beginning. And don't forget to reduce. Got to reduce or it doesn't work. So it's going to be 1 over 5 positive, and these both divide by 5, so it'll be -1 over 1. Okay, now it's time to just put it in, starting at the bottom. Always start at the bottom. And we're going to get 5x plus 1 and x minus 1. Wasn't that easy?